the weather compared to normal years. Which I kind of understand. Okay, that's no all the students are showing up today, but anyway, still have to continue our study. Check the 10. Okay. Because our presentation and report due date is next Monday, so I believe you guys will begin to meet, to begin to collaborate for the reports for each team. So if you are not aware of which team you belong to, please let me know. If your team has any internal problem you think I should be involved in solving the problem, or at least I should be informed by the problem, let me know. Okay, I'm here at any time so we can discuss, see what we can do. Okay, chapter 10. Let's continue our study on chapter 10. Last Friday's class, we begin to introduce two types of control charts, which are very useful for us to control our qualities. And the first control chart is the mean chart. That's about the second control chart we have introduced. Mean chart. And what's the other one? Mean. That's mean chart. And what another one? Is the range control chart. I think this what we can pretty everybody's relaxing, including myself. So it's mean control charts and the range control charts. They are useful for us to control the quality. We have discussed, right? Think about that. First, mean is very important. When we talk about the feature of a car, right? Or feature of the tires. How long a tire can last? Some good tires can last like 60,000 miles. Some average car tire can only last 40,000 miles. So that's the mean performance. It's 60,000 miles, the mean performance. But another important quality part is the range, the fluctuation of how long a tire can last. Right? So that's why we want to build these two separate control charts to measure our performance. And the formula I introduced here, if we don't know, if we know the standard deviation of a process, then we first have to calculate standard deviation of distributions of sample mean, notation sigma x bar, by standard deviation of the process sigma divided by the square roots of sample size n. Right, that's the formula. And then plug in to calculate the upper control limits and lower control limits of the mean chart. The second type is that if we don't know the standard deviation of the process, we can still build our control charts. Right? By using the charts we have introduced in the textbook, right? So for any sample size n, we find the corresponding A2 and then plug them into the formula, we can get the control chart. Range charts is pretty straightforward. We still have to refer to page 433, okay, and then you find the corresponding D3, the control factor, and D4, another control factor with the sample size n. That's how we build the control chart, R chart. And then we went through this example on last Friday to build the control charts for mean. And then continue today. Okay, same samples, same data. We want to build a control limits for the ranging charts. Here is the formula. Ranging charts is very straightforward. So UCL, upper control limit, is equal to D4 R bar, and LCL D3 R bar. Now, first question. For this example, how do you get the value of D4? How do you get the value of D4? Any volunteer? You need a volunteer from the student who has a textbook now. You guys that? What's the D4? 2.28, great. JJ, how do you get 2.28?
At the 84.
Because what is the sample size n here? What is the value of n? N equal to what? 4. N equal to 4, right? Agree, everyone? N equal to 4, then if you have a textbook, you will go to the page 433, and you will find that for corresponding value n equal to 4, right? And you find this row, that's n equal to 4. And then for n equal to 4, that's the corresponding D4 and D3 here. And D4, as JJ has found, is equal to 2.28, right, JJ?
Yes.
What about D3? What do you find in this chart?
0.
0. Okay. You can practice later when you come to your home and to find a textbook. Okay. Let's find by this way. Okay, I'll tell you this way. So D4 is equal to 2.28, D3 equal to 0. For n equal to 4. Now, you have to finish this problem. How to build the control limits. Give you guys 5 minutes should be enough. We have D3 and D4. You have to calculate. The only thing rest is in fact, what is the only thing rest? R bar. Right?
I don't know, R.
You know R? You know how to calculate R?
Is that like regression? Like
No, it's not regression. R is the range.
range? Oh,
Okay, you got that? Great.
It's the average of the range between the samples.
That's right.
The average, the range between the samples of each one.
Each column. So next bar would be 12 to 12. Nobody or not mistaken.
In fact, 12.11, right? Minus maximum minus minimum.
Oh, you do it for each sample.
That's right. That's the definition of R bar. R bar is calculated this way. R bar equal to summation I from 1 to k Ri divided by k. What is the value of k for this example? 5, because we have 5 samples, so k equal to 5. So you have to calculate the Ri for each sample, R1 until R5, and then take the average. Clear? Question? Last row, students? No? Okay, we'll come here. Now we are talking about range charts, not mean charts. So basically, for calculate R bar, you have to first calculate R1 until R5. So we have 5 samples. But each sample you can calculate range. How do you calculate range? No, this is the row is not the sample. Sample is the column. So 1, 2, 3, 4, 5. So one column corresponds to the 4 observation of a sample. So you have the range is the difference between the maximum and the minimum. So for each column, you calculate the range, which is maximum in this column minus the minimum in this column. And you take the average of these 5 samples, 5 ranges, and you get R bar.
Thank you.
So we don't. So we don't use the X bar.
No, we don't use that.
We use another for.
This information is only useful for mean charts. It's not so useful for mean charts.
That's right.
Wow. How come n is equal to 4 if we have 5 samples?
What is the value of n? N is the sample size.
So you get 0.0.
K is the how many samples you have. When you calculate R bar, you have to divide by 5 because you have 5 samples. Each sample has a range. Agree with me? And each sample size is equal to 4. So that's why sample size is equal to 4.
What you got?
Yeah. 0.046.
Yeah. I believe some student has already finished this question, so let's do it together. R bar is equal to summation I from 1 to k Ri divided by k. So what is the value of k here? How many samples do we have? 5. Great. Okay, so who can tell me the value of R1, the range for the first sample?
0.03.
0.03. How do you guess that, Franco?
12.11 minus 12.08.
That's great. Maximal, the type of the two maximal values. The first observation and the third observation, 12.11. Well, the minimal is the fourth observation, 12.08. So the range for the first sample is 0.03. It's clear for everyone? Clear? Why the first sample, the range is 0.03? Clear? 12.11 minus 12.08, maximum minus minimum. And remember, each column corresponds to one sample. The row is the observations within this sample, in this sample. So don't make it confused for yourself. So each column is a sample. So when you calculate range, we look at each column. So these observations, the maximum minus minimum. And then what's about the second sample? What's the range?
0.05.
0.05. Christine, how do you guys 0.05?
You take 12.15 minus 12.10.
Great. So it's the maximum in the first observation, 12.15 minus the third one minimum, 12.10. So you get 0.05. Then could you tell me the third one?
0.06.
0.06. The fourth one?
0.04.
0.04. Last one?
0.55.
0.05. That's great. Divided by 5, so you get R bar equal to
0.046.
46. And then we plug this number into the formula. Then it's become very straightforward. Anybody can tell me 2.28 times 0.46. Any volunteer? The last one.
0.148.
0.105. And this is equal to 0.
It's 0.046, not 0.46. Bottom.
Okay.
Yeah, or that doesn't matter.
Thank you.
Yep.
Okay. Okay, so that is the range chart. So it's from 0 to 0.105, which means okay, the sixth day. Let's say the sixth day you want to test the glue, right? If you have some samples, another 4 observations, if the fluctuation for these 4 observations is between 0 and 0.105 minutes, you think it's under control for the range chart. If that's about 0.1 minutes, 105 minutes, okay, and you think there's something wrong. So that's the way we use the range chart. Now, first question is that, does this make sense? The lower control limit is equal to 0. Does this make sense?
Depends on the product, I guess,
Depends on product.
that you're testing.
Okay. So do you think in this case it makes sense?
What's the product?
It's the glue. Not fancy as well, but
Glue.
Mhm.
I guess if it's supposed to be held to a certain standard,
Mhm.
it's fine to be above that standard. But if it's below that standard, they can get in trouble for false advertising and stuff like that.
That's right. That's right. But Aaron, we're not talking about the mean charts, right?
Okay.
If we talk about standard, like say, how long the glue should dry, that is what we have done for the Friday class. Now it's the range charts. We think about it. So the conclusion we get, okay, if we have collected a sample every day, any day. Then if the range of the sample collects for the glue to dry is between 0 to 0.105, it's normal. So my question is, if that's you have a sample, like say 4 observation, they have the same length, 12 minutes for the glue to dry. And you think it makes sense because the range is 0. It's in under control. Do you think it makes sense? 0. If the sample have 0 fluctuation, is under control. Is that scenario make sense for you?
Yeah, that'd be optimal. It means everything
That's
you're
right.
producing is exactly the same.
That's right. Like Jack, you said that's optimal. If you have this situation, you are probably very happy to find that. Well, that can have some concern because you think about is any fake number or something like that. So we'll see some example. We'll see the lower bound is a little bit higher than 0. If you look at the text, you will find that. Okay, when the sample size n become larger and larger, for example, until sample size equal to 6, D3 is still 0. So that means your lower control limit for the range is always 0 when your sample size less or equal to 6. But when your sample size continue to increase, D3 become positive number, which means your lower control limit for the range charge is not 0 anymore. What does this mean? Means, okay, if you have a large sample height, you shouldn't come up with the situation. The glue dry time is the same. If that's the same, maybe the measurement is not so accurate, maybe somebody make the fake number, you will have some concern. But when the sample size is small, like 4, it's totally understandable, it's perfect, right? Every glue dry in the same length. So that's why in this situation, 0 definitely makes sense. Definitely, upper bound is what we are so interested in, right? Upper bound is very important for our quality control. Okay, great discussion. Now, let's think about why we need. We probably already know that's why we need these 2 control charts. First, mean charts are very obvious for any products like the table, the chair, the computer, the car. We have so many specification standard. Okay, we tell our customer, if finally our products, these features is beyond our range or our specification, it's out of control. Customer won't be happy. It's very easy to understand why we need the mean charts or X-bar charts. On the other hand, our range charts is different story. You think about scenario B, right? Scenario B, okay, the process variability you can see day by day is increasing. It won't reflect in your mean control charts. Agree? Because the mean is still very stable, right? If you draw the X-bar charts, day 1, day 2, day 3, day 4, they are all under control. But if you draw the range chart here, the fluctuation become larger and larger, finally it's out of control. Do you think this scenario has some problem? Scenario B, do you think has problem? No or yes? No problem or potential problem?
It's a problem because it's beginning to, the ranges of the values are growing wider.
That's right. Like think about that. If you are in the McDonald's, right? Average drive-through waiting time probably is like 2 minutes. Well, it's very stable until day 1, day 2, day 3 becomes 3, 4, 6, 7, 8. Well, the average time, every time is still 2 minutes, but the range become 2, 3, 4, 7, 8, 9, 10. If some customer waste 10 minutes to get the order, this customer won't be happy. Well, even it only happen once or twice, he or she probably never come back to this McDonald's. So that can be a problem, right? But this problem can never show in your mean charts. Right? But for the range charts, it can show up. So that's why sometimes we have to use the range chart to control our quality. Because mean can't tell all the story. Like we have said, if 2 cars tell the same story, 30 miles per gallon. Okay, I have to do the survey. Some students say, you prefer a more stable miles per gallon performance cars instead of one car have like 20 or 40, will depend on whether you are lucky. So that's why our chart is so useful too. Clear for you guys? Okay, great. So how to use the mean and the range charts? We have to determine the initial control charts. We first need to obtain 20 to 25 samples. It looks like our simple example, we only have 5 samples. We should obtain 20 to 25 samples. Okay. And here we don't discuss, but for each sample, how many observations we should have? Still remember for business statistics course? For the sample size, what's the better number for us, or good number of sample size?
30?
Yeah, that's a magical number, Brento. I'm glad you still remember that. 30 is a magical number when we talk about statistics. When you collect sample, usually we should have a sample size larger than 30 because from the central limit theory, that's pretty complex. We can prove that when your sample size is greater than 30, usually the sampling distribution will follow normal distribution. Well, most of our conclusions are based on the assumption it's follow normal distribution. So that's why we need a sample size usually greater than 30. Right. Nowadays, it's not a big problem because nowadays it's pretty easy compared to like 20 years ago to collect sample. But remember that if you get a sample size larger than 30, that will be good. And then we compute the appropriate sample statistics like sample mean or sample range, establish these control limits. If any points fall outside of control limits, okay, if we find no out of control signal, assume the process in control. Like if you find any signal and search the root cause and correct assignable cause of variations. And continue to do that. Plot the data in the control chart and check for the out of control signal. Still, I want to remind you guys, since there's a type 1 and type 2 error exists, we have discussed on video 1's class. Even we have some points out of control, maybe like Shakyoni's weights, well, it's totally under control, but we can't determine from the chart. We need to dig out. If you don't find any problem after you dig really hard, maybe that can be a type 1 error, right? It shows out of control, but in fact it's a normal distribution, it's still normal. On the other hand, even there's nothing abnormal, like these charts, when you may make the type 2 error, they already have some problem you don't know. But probably we don't do anything, right? Because you probably want to trust these charts. You don't want to put some manual efforts, even it's still show under control. But this part, if you dig really hard, you still didn't find any problem. That's okay. Well, sometimes that's just a normal distribution. Okay, upper tail or lower tail. So that's how we use these control charts. Okay, we have talked about control charts for variables, which means that can be measured, like mean or ranges can be measured by a number. Next, we'll talk about control charts for attributes. Well, which attribute generate data that can't be counted. For example, the P chart, which is the percentage chart. Okay, it's not the number, it's a percentage. The control charts used to monitor the proportion of defective in a process. Think about let's say we have to start our, let's say we have a very old used car, right? Car performance is not so stable. The worst situation is that you can't start your car whenever you want, or sometimes you can't. So one way to measure the performance of this car is that the percentage when you start your engine, it can't start, like 90%. Well, brand new car should be 100%, and I believe most cars is close to 100%. But for a pretty old car, that can be like 70%, 80%. Well, this should be measured by the percentage, right? When you try to start your car, you start engine, right? While your ignition engine can work, how many times? What's the percentage you can start it successfully? Another chart is the control chart, is C chart. Control chart used to monitor the number of defects. I still talk about used car. When we try to buy the used car, it's different with the criteria we try to buy the brand new car, right? Used car, we go to the, how do you say, we check the history of the used car and the accidents. Well, if there's 1, 2, 3 accidents, that's counts, right? Maybe your threshold is 2 accidents. If there's more than 2 accidents, you think it's not my choice, for sure. So that's the C chart can be very useful. If you count the number of defects, right? Another thing you can count is how many dents or scratch in this used car, right? Especially for girls, maybe that's at most 2 or 3 scratch. That's all. Maybe for boy, 10, still acceptable as long as it's cheap, right? But there must be some criteria. You can't really measure by a number, but you can measure by the counting number. So that's why P charts and the C charts are also very useful for us to control the quality. Okay, for P charts, if we have to place our observation in two categories, that can be very useful, right? Good or bad? Well, I think that's for adults what we seldom use this criterion to categorize people or phenomena, just good or bad. But my daughter, she really categorize people or things into these two categories, good or bad. Right? Pass or fail, we still categorize that in that way. Some of our course has no A, B, C, D. It's just pass or fail. Even as in this course, when any student gets above D, will be categorized as pass. F is the category of fail. Operates or don't operate. So if you want to measure the performance, okay, of the things by these two categories, then percentage chart is perfect for this situation. Right? So how do you calculate or build the P charts? So first we have to compute the percentage P bar, which is the total number of defectives divided by total number of observations. So, for example, even in our school business, okay, we have the A, B, C, D, F system, but we still have one very important measurement to measure our overall performance of our students or our teaching quality. That's what we call the DWF rates, which means in this session, how many students at the end gets D, F, or withdraw from the class? Well, the rest student who gets A, B, C belong to a different category. So if we want to measure the performance of students in one class, like say operation management, and then we can calculate the percentage of DFW. Right? DFW, what's the percentage? I think I never give any F in face-to-face session. I do give a couple of D, the grade of D, in operation management before. I hope I don't need to give any F or D in this session, but we'll see. We do have several W of this, you can understand. Some students maybe have their personal issue, they withdraw at the middle of the semester. It's totally understandable. So, but this can measure the performance of the session, maybe also evaluate the teacher's performance. So, if you have these two categories, then for this example, you calculate total number of DFW in this session of defective. You think it is maybe not defective, whatever you think has problem. Total number of observation, which is total number of the initial registered students at the beginning of the semester. Right? That's the P bar. And then you calculate the standard deviation of P bar, which is sigma has P. It's calculated this way. It's the square roots P bar times 1 minus P bar divided by N. Well, you know N is equal to, what's the value? What's sample size? Right? In sample. Here we have whatever student registered at the beginning of this semester is a sample size. Right? And then upper control limits for the P charts is P bar plus Z value, 3 sigma, 2 sigma, your criteria, times sigma has P. And the lower control limit P bar minus Z sigma has P. Has everyone written down these formulas? So we have an example soon. Well, that's the reason I explained so long time for this page. I'll give you some time to write down this. Okay, now we move on. Okay, example. Before shipping the loan mobiles to dealers, an inspector wants to start each mobile and loads any that do not start on the first try. Okay, just fail or succeed. Right? The lot size is 100 mobiles, which means the sample size is 100 mobiles. And an average of 4 mobiles did not start. Right, so I tell you that's 4%. Using the P chart, determine the 2 sigma control limit for this problem. Okay, come back to our formula. First, we calculate P bar is very straightforward. Second, I want to ask you guys, what's the Z value here for this example? What's the Z value for this example? What's the value of Z?
2.
2. Why, Aaron?
2 sigma.
2 sigma. Great. Last sentence is already tell you the company want to use the 2 sigma to control their quantity. Like last example, we have used the glue is 3 sigma. So different company they have different criteria of the control. Right? The small of the sigma, if 2 sigma, you have a tighter control or higher criteria for your products. If you 3 sigma, 4 sigma, you have pretty loose criteria for your products. But here is 2 sigma. And then next I will give you guys 5 minutes. Try to finish these questions. Follow these formulas. Okay. That's 100 molars, 4 digital steps, and 2 sigma control limit. As you think, should be enough. Huh? Okay. How? Okay. P. Okay. P bar is the. That's one. You see. Two decimal.
Gotcha. 100.
Yeah. So it's a sample size, right?
Do we actually need to find Z score?
No, because if the question is probability, let's say 95% control, then you have to find from the Z table. But here already give you 2 sig and Z 2. Okay. Yeah. Remember to square root standards.
Square root.
Yeah. That's for is that this value? Yeah, believe so. One zero zero times look it over, so 1.6 divided by
0.019.
100 and then square root. Yeah, that's square root. Yeah. Okay, I got something. Anyway, should. Yeah. Yeah. Great.
Wait. 0.01.
Any idea?
Maybe
There's something wrong here. The square root is for the whole
100.
equal the denominator.
no.
It's like
Very good. Z these two sigma.
Most students also did get 0.0126. Yeah, so, yeah, maybe.
Double check. All right. So. I'm see many students has already finished these questions. So let's do this together. So first we have to calculate the sigma standard deviation of the percentage, which is equal to p bar times 1 minus p bar divided by n. Take the square roots. So first question, what is the value of p bar here?
104.
0.04.
Yes, 4%. Why is 4%?
It's 7.
Yeah, that's right. But it's in fact 4 divided by 100, right?
Yeah.
4 defect divided by 100, so it's 0.04 times 1 minus 0.04 divided by n. And what is the sample size here? 100. Great. So you get
0.1.
Right.
0196.
That's what I guess. You guys the same number? Okay, great. Okay, then it's pretty straightforward. UCLP is equal to P bar plus Z value sigma, which is equal to 0.04 times 2 times 0.0196. Who can tell me the final results of the upper control limit? Equal to
0.079.
0.079. Correct? Everyone can same? Lower control limit. P bar minus Z value sigma P. So just tell me the final value.
0.001.
Okay. Which means in the future, if you have another 100 lawnmower you want to test the quality, right? If you have the failure rate between, that is almost 0, like say, 0.1%, 0 to 8% is under control. If you have the lawnmower, this sample has exact 8 mower can't start, then it's also control because it's purely 7.9%, which is the upper control limit. Right? If you have 8, 9, or 10 or more lawnmower can't start initially, then you think there's something wrong with your production, or at least today's production. So that's how we.
Normally, or that's just an example?
Huh?
Normally, or that's just an example? Like 8% is like for businesses.
This is I believe is an example. It's not. It depends on which company, and I truly believe this is too hard. If you think I truly believe it's too hard, but you never know, right? But it's just example. Doesn't tell any background of this lawnmower. Well, and also if you think of difference in the like car, well, it's too high. If you have 8% of the car you can't start initially, there's no way you can sell them. But lawnmower, I don't know, but I'm not sure about you guys. But when I purchased the first lawnmower 3 years ago, well, in the sales store in the Southern Pines, well, doesn't work. I tried really hard. I almost broke my arm trying to start that. I think I don't know the trick because I go to YouTube to watch 20 videos how to start a lawnmower. I know it's very stupid, seems now, right? How do you start lawnmower? I think anything I don't know, but just pull, can't start 20 times. I try really hard and send it back to see how they fix that. Well, it's very interesting. I didn't know. I think that's very hard. I don't know. Is any trick? I find no trick at all. Right? That's my experience. That's really at least my lawnmower is belong to this 4% in this example. But what I want to say is that you have to first start your product. For example, maybe you like Jen, you don't know your lawnmower performance. You want to have perfect, but you don't know. But what you can do that, we think, okay, this month's production line is perfect. What we can do, we collect sample of this month's production. We test our sample. If this month we can say, okay, 3% is a normal, then we can build this control chart. Okay, then future we use this month's performance. Okay, this is our control chart from 0 to 8%. We think in the future, several months or 1 or 2 years, if we don't upgrade our system, then this should be our criteria. That's what you should do. Sometimes we don't know what is the really criteria we should follow, right? You produce something you don't know, right? And it's really hard to let the customer tell you, except me, right? Try 20 times, doesn't work. And then you should test by yourself, build this control charts. This can be useful for yourself to check your quality. But whenever you did upgrade, while you change the scenario and have a new employer, you have to do it again to build a new control charts. Okay. Any other questions? Okay. All right, here's the last control chart we will introduce in this chapter. Okay, I think now it's very straightforward for you guys after you went through the 3 control charts. So if we really care about the number of occurrences, the units measure can be counted. Non-occurrence cannot be counted, like scratch, chip, dents, cracks, breaks or tears, bacterial pollutants per unit of volume, and how many calls, how many complaints you get from customers per hour. And if that's very important for you, like say for example customer service, right? For given 1 hour, what is the average number of complaint you get? Now then we can build this count chart, which is very straightforward. UCL, upper control limits is C, the counted number, plus Z, how many sigma you want to control, square root of C. Lower control limit C is equal to C minus Z square root of C. That's I think the simplest formula as this for this chapter. Okay. An inspector, example, an inspector found an average, well, let me write the formula for you in case some students don't have the slides here. So upper control limit is C plus Z square root of C. Lower control limit is equal to C minus Z square root of C. Alright, so that's use formula to build the control chart. Let's go to the example. So an inspector found an average of 3.9 scratches in the exterior paint of each of the automobiles being prepared for shipment to dealers. How to use the C chart, the count chart, determine the 2 sigma control limits for this problem. Okay, you guys 3 minutes should be enough. Okay, finish this question. Not enough? I can give 4 minutes if you want. Okay. Okay. My students have already finished this question. So, any volunteer can tell me how to build the upper control limit? Anyone?
3.9
3.9
plus 2
plus 2.
times the square root of 3.9.
That's great. What's the final number you got?
7.85.
7.85. Agree? Okay. What's about the lower control limit? Any volunteer?
Same thing.
Same, not the same.
By
Not the
minus.
exact same thing, right?
Same thing with minus.
And what's his final result?
Negative 105.
Negative
0.05.
0.05.
Then when we really talk about this chart, ideally we shouldn't have the negative number. We should build a chart from 0 to 7.7 because negative really doesn't make any sense.
Yeah.
Right? But when you do the calculation, definitely it's negative. But we know that you can also say it's negative, but it will never happen for the counted value. So questions?
So, on the homework, if we're given a problem like this, would we give the answer but just say the range is from 0 to 7.85? Or
I would still prefer you calculate negative number, but for the final answer of the range
Is
for the
zero.
number is 0
Right,
because
okay.
you think about that when you work in the industry, right? Maybe you understand that negative is the calculated result and it's never happened, doesn't make any problem. But you give this chance to employee, especially the first level employee, they can be bigly confused whether they will trust your result. You give a negative number, still, how can you build this chart, right? So that can be a problem. Well, if people understand, right, because negative doesn't matter, negative 1,000 still doesn't matter because you will never reach the negative 1,000. It's the same as 0. Wow. But when in the reality, you shouldn't give a negative number to make it confused for others.
Right.
Okay. Any other questions? Great. Okay, that's we have introduced all 4 types of the control charts, and then we'll talk about the managerial consideration by using these 4 types of control charts. Quick review. Tell me, what are the 4 types of control charts?
Range,
Range,
mean,
mean,
P and C.
P and C?
PNC, percentage and counts. Yeah, PNC. Great. Okay, the first question: what's point in the process we should use the control charts? What's points we should use the control charts? In your opinion?
Maybe kind of in like the early stages of your
Early
product.
stage.
Like when you sell them, and then you get the feedback from customers.
But that's a different answer. Early stage. That's the final, almost the final stage.
Okay.
Yeah, definitely the final stage is very important. Like we have example we have seen, alright. For example, the lawnmower before you ship to the dealer, right? And what else? Example, I think the C is also something about for the shipping, right? So it's before automobile being prepared to shipment. So that's the final stage. But for the glue example, I believe it can be the internal test, right? Internal test before you really do anything. But we have a lot of discussion, right? If that's raw material is important, you probably want to check the quality of raw material. But most situation very important to use them for the finished good before ship to the customer or dealership, whatever you can't get it back. Sample size, we have discussed that. My Branko still remember this magical number and 30. So, well, still this is not a scientific definition. You have to be 30. Well, 30 can guarantee unequal result. What's the difference between 30 and 29? There's no significant difference between 30 and 29. It's just our experience. 30, about 30 is better. But you can't say it's a discontinuous function or 29 is fail, 30 successful. No. But the larger the better, we know the rule, but we also understand, well, the larger the sample probably put more efforts, more investment to get the sample. So, but you should keep that in mind. Okay, general rule is 30 or at least around 30. Type of control chart, we have a lot of discussion. Variable charts is mean charts and ranging charts. Well, they are very useful. But if something like the percentage of counts, that can't be measured by the number, then attribute charts, which include P chart and C chart, can be widely used. Okay, that's the end of today's class. I'll see you guys on